Thank you for this lightning talk. I'm still a bit light from yesterday evening, but I'll share you my little Sunday experiment where I try to include our newest, most productive colleague at the company, OpenAI, in the collaborative modeling process that we do for creating digital products. I'm Michael. I was here last year. I'm the CTO of Lemon. And when life gives you lemons, I will say, let us create awesome digital experience for you to solve those lemon problems. It's a lightning talk, so I go further. We design very awesome products in a variety of domains, from Linker on the left side, which is a data consent sharing application, to a cooking app for a very famous cook in Belgium, to on the right, a platform where you can actually calculate how much your children have to pay when you die, because it's a will generation platform. So the applications, they have actually nothing in common from a domain perspective, but under the hood, it's all by default CQRS event sourcing in a company. But I'm not here to talk about that part, but about collaborative modeling. Because to come up with great digital experiences, and also like yesterday in the talk, you really need to understand the problems and to collaborate on the domain you want to solve the problem for. And for me, it's more of an art than actually something that you can learn. You learn it by doing like an art. And for that, we have a 4-track approach. The first one is we always start with design sprints, because a lot of customers, they come to us with problems which are actually not their real problems, and then we come up with validated solutions. Then, most of the time, there results in digital products that we need to scope, and then comes the fun part, modeling and architecture, and getting actually into the problem space. And then it's code, eat, repeat, and shipping a product. And on that Sunday, when I was reflecting on the projects that were successful, I realized that the projects where both the business, the engineers, the testers, the UX designers were all together modeling, that were the successful projects. However, we had a Monday morning problem. We do 3 Amigo meetings. It's a lightning talk, so I can't go into detail what it is, but you put all the people in the same room and you start modeling, talking about the problem space until you have it crystal clear. But the issue is that no one in our company really likes to do event modeling or come up with meaningful names, especially writing feature files in Gherkin. It's like a more spec'd out example mapping exercise. It's really hard, and there was always a discussion whose responsibility is. The engineers say, no, it's a product owner. The product owners say, no, it's way too technical, it's for the engineers, and so on. So I thought, can natural language, because we have to define our events or feature files in natural language, can AI help us? And so I said, okay, let's give it a try. In our 3 Amigos meeting, these are the inputs. So you have a certain feature, use it for an application where you need to check whether your address, your residence, is eligible for fiber internet. It's for an internet provider. So it's a very simple use case. So here we have a user flow. I'm not going into the details, it's just the input for the model. We have spec'd out mockups that really display, okay, this is the feature, to select your address and to see is it eligible or not. And then we come up with, do event modeling, and at the end, we come up with feature files. But no one likes to write them. So I said, okay, let's give it a chance. So I just go to Miro, I just copy-paste this. Actually, I already did it. Put it in OpenAI. I made a little custom AI, and just said, okay, this is an application that allows consumer to check whether the residence is eligible for fiber or not. Can you come up with some inspiration for good event names, command names, and also some scenarios for Gherkin feature files? And let's hope that it's not hallucinating this time. Hope the internet works. Oh yeah, it's coming. So it really understands that's about an address. It also knows, like you have to screen where you have to enter your postal code. You need to select actually your address from the list. And then you have to, at the end you have 2 options. Either your address is eligible or not. And then it comes up with feature files. I'm not going into the detail, but this really helped us to quick start from this and start like, okay, that's what it's about. You can kind of copy the Gherkin files. Don't copy them in your BDD scripts because they are not perfect, but it gives you a head start, and you don't have to start from a blank canvas in Miro. Like I said, it's far from perfect because, for example, all the events here are generated, and note those are different because I did this yesterday, so it's not consistent, which is painful. But it's really UI-driven because all the inputs you do, it's UI, because residence address submitted, postal code selected, I don't need an event for that in my backend system. I just want, and that's actually our events, address is fiber eligible or not. Or, yeah, I want to be opted in to notify when it becomes fiber eligible. Those things we need to store in our event store. So that it really helps, and it also gives some explanation. So it really helps us to come up with those events, and especially for juniors, it really gives some kind of guidance. These are like a feature file. It even comes up with examples. It takes it from the UI. It just copied the examples. So they did pretty well, but not consistently. Skipping that. If you do this with normal OpenAI, then it will fail more miserably. So I created the custom instruction, and the custom, if you have the Plus license, you can create your own OpenAI bot. And there I really said it's a colleague to generate Gherkin files, commands and queries, use the BDD principles, past tenses, and also we are a Belgian company, so most designs are in Dutch. I don't want Dutch event names in my backend, so translate everything to English. And by tweaking that, it kind of does the job. So my learnings, it's far from perfect. I won't use it to just copy-paste it, but it really helps, like I said. It makes it more fun. Like before it was, no, I don't want to write feature files. Now you come up, you can prep it, and there is something, and it does something with the mindset. And it also spots also the if-else cases. Because, for example, I prompted, if there is something optional in the UI, yeah, that's probably some kind of business rule why it's optional. So it's not consistent because it has a limited context AI. Like me, I'm not able to fully grasp the blue book, either is AI not. So the context is limited, but it speeds up the process, and it's like a brainstorm partner. Sometimes he's a bit on drugs, but it really helps. The roadmap or potential next steps. We're looking to connect it to GitHub, a repository, that it can really learn from our code base, also from the feature files in there, and that we also can enter a domain glossary so that it will hallucinate less. So then we are able to more profile the model. And then at some point, we already looked at, in Miro, you can create plugins. We can then put OpenAI in it. And then maybe at some point, it can output stickies in Miro with event names. So it kind of, in my head, it already works. Now it's just to find a few more free Sundays to build it. So that was my lightning talk on experimenting with my newest colleague, OpenAI. Thank you for listening.
Super on time. So that's great. So maybe you can do 2 questions. If people have a question, of course.
I know you skipped over it in the interest of time, but what are Free Amigo meetings?
Free Amigo meetings is, so before we start actually developing on the feature, we really sit down with a UXer, the business person, especially the client actually, and technical people. And the goal is to have no assumptions when you start developing. So all business requirements, all domains terms get reclarified. So everyone is in there so that you can ask all questions. Also, developers often have good input to optimize the user experience because they say we can do this with 1 call less, so it's 1 click less. And that's what and there actually, we always say in the phases before where we come up with the spec'd out Figma designs, we say 80% is fixed. And during those 3 amigos, you really share the domain knowledge, you transfer it to your developers, and you really make them experts of that domain. And once we started doing that, we built less wrong features, and that's the biggest gain out of it. So, all right. Then,
perhaps anything else? I think it's okay if you already unplug it for the next one. That's true, but And if not, then I know Jan is going to put up his laptop. But it's not Jan who's going to talk yet, as far as I'm aware. I think he's next after this. So first we have Marc Klefter, who I've known for a couple of years now, I think. He quite recently joined us at AxonIQ, and I'm extremely happy about that. Yeah, thanks. Because well, he knows a great deal about event modeling and making event source systems. So I'm confident he's going to talk about that. So good luck.
Thank you. Hi, everybody. You're probably familiar with event sourcing, obviously. Data architecture, maybe, and especially event sourcing for data architecture. What does that mean? I thought we would explore that in this talk. Okay. Well, it's not my laptop. Data architecture, what is it? According to Wikipedia, it aims to set data standards for data systems as a vision or model of the eventual interactions between those data systems. I think that could be a bit clearer, but it has obviously something to do with sharing data. Data systems, maybe that's a bit unclear. If we switch data systems for bounded contexts, I think that's maybe a little bit obvious. We have a bounded context that owns some domain data, and it needs to share that data with other contexts. And the thing that makes it possible to share data is something we sometimes call a data product. So a data product is something you can envision sitting at the boundary of a context. It's part of it. And it basically sources domain data from the context and then makes it available to the outside world via these so-called output ports. So domain data, in our case, are our internal event streams that you can find in Event Store, like Axon Server. And we map those internal event streams to external equivalents and make them available to downstream consumers, downstream contexts. So if data products are the logical units that make data architectures possible, how do we design and build these data products? Especially event-driven ones, which is of interest here. Of course, we turn to our favorite modeling technique, event modeling. And as you can see here, we have 3 swim lanes that represent 3 bounded contexts. So we have order processing that has certain events occurring, and for example, when order submitted happens, we need to induce or trigger a state change in the inventory context. Likewise, for order completed, it needs to trigger a state change in shipping. So if we put on a data lens and try to make some observations, we could deduce the following. First, data ownership in a context. We can see that it's fully encapsulated in each swim lane. We also know the inputs and the invariants that trigger state changes, that yields events in a context. What we choose to expose and how we do it, that's the read model's responsibility, you might say. So here you can see that a read model, in this case, is nothing more than translating an internal event to an external equivalent, something you can do with an event broker like Kafka, for example. So an external event is published from order processing. The downstream consumer, could be inventory, gets that external event and translates that into a command, which yields a state change in inventory. And finally, these event streams, for order updated events here, they can be source or consumer aligned, meaning that we can study the interactions between contexts using event modeling, and if we see that, in this example, order processing interacts a lot with other contexts, that could signal that the external events are general purpose. But if order processing only interacts mostly or all the time with another context, that means that it caters more to that specific context. It's more consumer aligned. So this sounds great because these read models can then serve as drivers for data products or the basis for them. And what it enables data teams to do is shift left in their responsibilities. So data teams can get closer to operational data where it's already structured, schematized, and so forth, and use that for their data products and the data scenarios that they need to implement. So using read models as a basis, that's where data people can commence their work. There's a practical concern here, however, that is, I think, a major showstopper today. How do data people, data teams, actually discover and access the internal event streams and make use of them? Preferably without writing code, if there are no engineering resources available in data teams. Basically, I hear the refrain often, we have an application team, they don't care about us, they don't hear our concerns, so we're sort of left aside when we want to build analytics solutions, for example. So this kind of, again, showstopper that is significant. And let's work through a scenario and see what a data team might actually want to accomplish. So, if we have the order processing context and realize it as an order service, you might have a data team already established, something using a data platform like MongoDB Atlas in this case. So the job is taking an internal event, order completed, down to the very left-hand side where a materialized view displays real-time analytics about processed orders to whoever is interested. In this case, it seems that an internal event from order service needs to be translated, mapped onto Kafka, which is what MongoDB Atlas sources its data from, and then it can produce the view that is necessary. So as a data team, you would have to simply do this transformation. Nothing too big. You simply realize that the read model is just mapping this internal event to the external one, publishing on to the Kafka broker that MongoDB expects. But again, doing this in practice without involving the application team, the operational side, is not always the easiest thing. So if I were to dream up something to provide a data team, I would call it an Axon data connector. And I would conceptualize it as something that, again, is positioned just at the boundary. It allows the data team to discover that there is an Axon server, there are contexts in Axon server, event streams that I can access, read-only. I can collect them, I can transform the events and distribute them on these output ports, depending on where I'm supposed to send them to. I need to maintain a schema that correlates internal to external fields, so make sure that if something unexpectedly happens with an internal field in an event, maybe we should stop publishing events until we fix that, for example. So we need a control plane that is sophisticated enough for our data purposes. We might also, again, want to avoid coding too much, so maybe we would like to plug in a stream processing framework like Flink, etc. So we want a data connector to be comprehensive enough in terms of features that data engineers, analysts understand, have previously used, and then on their own build the data products that are necessary for other parts of the organization, other contexts. Now, if you have this in place, it opens up a number of possibilities, not only the scenario just described with MongoDB Atlas as a data platform, for example, but something I'm particularly interested in is using event sourcing for RAG, or augmenting prompts to LLMs with real-time contextual data. So with an Axon data connector, we can, for example, on an output port, create embeddings as we get events. We store them in a vector DB, and we can then enhance our prompts. So we can, if you have a big furniture retailer in Sweden, you can maybe ask questions such as, how many orders have not been paid yet? And we can also exploit the fact that entities have event streams, and they have a relationship between events. So we could use that to maybe predict future states, such as, given this event for an order, say order submitted, we just started processing the order, when will it be completed? Or will it be completed? So this type of even more rich augmentation can be made possible, given that we source it using something like an Axon data connector and then manipulated, in this case, for embeddings. So liberating the read side, I call it, to make sure that data teams can go wild and play around with whatever the operational side with Axon Server, for example, are able to produce. So if you find all of this interesting, and I know you do, please reach out. I'd love to explore this further with you. So you can reach me on my email address or LinkedIn, or grab me. I'm here, of course, for the rest of the day. So looking forward to interesting discussions. Thank you.
Super nice.
I know.
Cool stuff. Yeah, again, just one. Or in this case, actually just one, because you don't have that much time. So is there a question for Marc? And if not, then you'll just find him somewhere in the hallways after this.
I have a question for myself.
Oh, okay. Yeah.
Is the Axon data connector available? No, sadly no. But it's something I want to see if it's something we can realize maybe in the near future. Well,
Cool.
all right, thank you.
Work. No, joking aside. So here we have Simon Zambrovski and Jan Galinski. Yes, please grab one of the microphones. I've known these people for quite a bit already. So they surpass you, Marc. I know them for more years than I know you. Nothing wrong about that. I know that they're going to share something very interesting, or at least I find this very important to have, well, a different kind of serializer. So I guess it's going to be interesting for other people as well. So with that said, I'm going to give Jan the microphone and give them a warm applause.
Hello, folks. Thank you for joining. So, yeah, I would like to tell you something about Apache Avro. The title says it's about serialization, but we will not focus as much on serialization, surprisingly, but on some other nice features. This is Jan, my friend and my colleague. My name is Simon. We are both developers. We work for a German consultancy called Holisticon. Some quick facts. We are pretty long time on the market. And if you're interested about that, there is Toasty. You can speak with him. He will explain you what we're doing and how we can help you. We are facing the problem of implementing pretty complex systems by large customers. And by doing this, we, of course, apply some magic techniques of domain-driven design and CQRS to ease up our life a little bit. However, there are still some challenges we encounter, and let me introduce some of them. So we usually start with some kind of collaborative modeling technique or, in general, understanding the domain. And there you see that the messages that we're using, these are the first-class citizen. So it doesn't matter what kind of method you're using, you come up with this messaging. And using these messages, we describe system behavior and system state. And as we all learned, the Axon way of thinking, there are at least 3 types of them, actually more. And they have specific semantics, and we have to understand this semantics. And this is a language how we express our system communication. Along with these messages, we need to achieve this business AT alignment, and we communicate with the business people also in this ubiquitous language that we established together with them. So it's not about strings and ints, but it's usually about customer address and your amount and whatever. So it gets more precise semantics. Speaking about events, yeah, we want to save them forever, right? Append-only event store, we never delete them. So we probably will try to read these events years after we have written them. So this is an important thing to just think about. You are writing something, you will need to read it 20 years later. And if you want to change this event, you want to make sure that it's somehow compatible to what you've written there, right? So, I mean, can I still read it in 20 years if I do these tweaks? So, in the end, you want to make sure it's not on a single developer that maybe understood the requirements correctly and hacked it in some IDE. And that's the only true representation of what has been finally stored for 20 years in your event store. So let's look on the development side. So what do we have there? So first of all, if the system is large enough or complex enough, there are multiple services involved, maybe implement in different languages, different ecosystems, and we will need to share this meaning of these commands, events, and queries among these systems, right? And among the teams that are building and responsible for those services. There are some details, so we need to make sure that if we evolve over time, we're using the correct revision, and everyone knows on the same page what kind of message we're using. And the serialization format matters, right? So there are small details how you can break it actually just by configuring part of your Jackson serializer differently, and then you just can't read the message. The semantics of the messages that Axon frameworks impose requires you as a developer to implement the handlers for all these messages, right? And you shouldn't do any mistakes ever, right? You should just not do it. On the operation side, if we speak about serialization and storage of messages, this reading and writing happens very often. So the overhead of doing this should be as less as possible, right? On the same time, we've seen it in the CWAR talk today. If it takes just too much space on your disk, even if the disk is cheap, you will get some performance problems actually, and maybe also sizing problems of your system. So it should be compact. And in the end, if the business decides that this message should be changed, then you need to come up with smart app clusters, and somehow you need to distribute these app clusters to all over the system. So it's not that easy. And quality assurance, of course, we're not making any errors in the development, but still it's nicer to know that there are no uncovered functionality in our handlers for these messages and app clusters. So we should address it somehow. So a lot of challenges. Maybe Jan will help us with that.
Yeah, you might have enough problems on your own already. So lucky for all of us, we are engineers, so we bought not a solution, we bought the solution for all your problems today. And you might have guessed there was a hint in the title. It's Apache Avro combined with our Axon Avro extension we built on top. So who of you heard of Avro before? Cool. Who used Avro before? In production. Okay, this might change after this talk, but kudos. So I could talk about Avro for an hour at least, but for now it's a mature specification for schema and serialization. It's quite popular in large data streaming, and it's an integral component of the Confluent Kafka ecosystem. I'm not sure if I'm allowed to say Confluent on stage. Confluent. Let's see what happens. For now, the important thing is it consists of basically two components. The one is a schema definition language, so I can build data structures based on primitive components, and I can express message signature behavior or protocol behavior. And it's also a specification format, so if I have data that is compliant to the schema I specified, I can serialize and store this data. As you could see down in the corner, JSON is a valid Avro serialization format, which is good because it's human readable, but it's boring, so we focus on the binary, especially the single object encoding today. If you have never seen Avro before, which only a few of you are, this is an example. So here we built a bank, of course. So we have a create bank account command with basically two fields, the account ID and the initial balance. And something I like to do on stage, scrolling down. And we created a message, or in this case, a use case behavior, you might say, create bank account. And we basically say that when you send a request with a create command, you will either get a created event or domain exception, in this case, initial balance invalid. So let's see how this could help to meet the challenges Simon mentioned. So you design schema first, you do your event modeling, storming thing, and you immediately start to put all the data that is required for all your messages in this type system. So business and IT somehow have to learn and align on this Avro JSON language. You do the same for the interaction behavior, as we saw, command, issues, event, or exception. And then you store this text document in some central registry, which could be a GitHub repo or file, folder, anything. If you want, you can extend for this. It's not just a string, it's a custom ID, Simon mentioned, and it's a built-in feature of Avro, enhance it by logical types and add meaning to primitive attributes. And what we use heavily, you can also extend the schema definition by your own custom fields, and we use it for a small DSL-like approach to say this is a command, this is a query, to get all these things running. In evolution, what might seem strange at first, Avro doesn't really think in versions. So there's no version 1 and a version 2. Avro just says, there was a schema that you used to serialize the data, and here's a schema I want to use to deserialize the data. And as long as those are compatible, I can do it. So yeah, basically, they are more than just works, does not work. Again, 1 hour. Give it for now. To make this work, we generate a fingerprint, it's called, or hash code, you might say, of the writer schema and embed it in the serialized message, so we can then check it. And in upcasting, it's a really nice feature because then you can just compare the schema on a JSON level and you get the information if it's compatible or not without writing classes and tests. During development, we do not longer share the versioned libraries containing commands and events. Basically, share the protocol definition, and then we generate the types, interfaces, everything we need. You will see it right now. For operation, we use the serializer interface Axon framework provides to have an Avro serializer, similar to the CBOR serializer we saw this morning. We did some measuring. We are in the time, so from the performance level where Jackson is today as well. We store single object binary, and we notice that we have, let's say, at least 10% size advantage compared to CBOR, because it's index-based without any keys and properties. And we had the same problem. We need a plugin for the server to have the JSON model available in the dashboard. And we cannot make any mistakes anymore because everything is generated from the specification. Business never makes mistakes, so developers are happy. Let's do a quick demo. Simon told me not to bring my IDE, so I have just some screens. We have a command model and a query model for our banking application. As you can see here, the command model is just your typical Axon aggregate. We have command handlers and event sourcing handlers. But you see the annotation stuff is missing, mystery. And the same is for the projection. We have query handlers and event handlers. Annotations are missing. Because, as you might have guessed, we have this protocol definition. So we have the create bank account command, which leads to this generated Kotlin data class. And we have this message interaction. This leads to the command handler interface defining the behavior. We also do this for event sourcing, for the queries, and something I really like, extension functions for the query gateway. You can see here that the query type and the response type are combined, so I cannot accidentally ask for an optional and the result is a single. And this really works. I'm really proud about this. So now it's a live demo. You just see the bank application run. But I really need to have this thrill of running a console application on stage. And with that, I give back to Simon.
So waiting till it is done, right? Okay. Yeah. Okay, so what I showed you today. So first of all, we believe that Schema-First is a very good idea for doing domain-driven design, and especially for also expressing your domain specifics in your ubiquitous language. And it helps your business IT alignment. Apache Avro is pretty powerful because it supports this approach and also can be used as a serialization platform and format. And you can do code generation out of that, and then you can avoid making stupid mistakes, forgetting important stuff. You still need to implement business logic. I'm sorry about that, but this is, yeah, maybe next time. So what we were working on was a pluggable Kotlin generator. Basically, what you've seen is just one flavor of how you can do this. Of course, you can do it differently, and you can configure what you want to do. We have a prototype implementation of Axon Avro as an extension, bringing the serializer and the Axon server plugin to read the binary in the dashboard. We are not finished yet, so there are some must features we need to cover. So we thought we were done with logical value types, but actually we're not, so we have to improve that. So to get the custom logical types in your event command and queries, we want to improve the registry support, and then we have a lot of ideas what to look at. One of them is, for example, bring the geomoticals supports. This is the ability to annotate your architecture inside of your code, and then you could RQUnit it, test it, whatever. We could derive documentation, so starting from event modeling map, going to the generation, specifying, generating an event modeling map, and comparing what you wanted to build and what you're actually building. So it could be a kind of a round trip. We are very focused looking on the F model, and we were happy to join the workshop yesterday where we saw a lot of that coming, and I think we can also deliver artifacts fully compliant to that way of thinking, and even some crazy ideas about research. So as Christian mentioned, it could be useful to have events in TypeScript maybe, if you do these projections directly. And maybe something like data protection can also be part of the schema definition, where just mark fields to be sensible. And if you have any questions on serialization, ask us. We are here. And thank you very much.
Thank you.
It was very good that Michael and Marc were a bit faster, because that allowed you guys a bit more time. So I think we can still do one question, I think. If I look at the time, if anybody has one. Yeah. Okay.
Sorry. For those of you who are interested to know more about Avro Serializer and Axon Avro, I did a podcast recording with Jan and Simon now about 3 years ago, believe it or not. So check it out on Exploring Axon. And yeah, what's that? I said his comment. I told him.
Thanks.
Were you able to actually convince business to write the Avro spec themselves?
Short answer, no. And this is still prototype levels. So we used Avro in production for the last project, but we wrote it ourselves as developers, and we used the built-in Java generator from Apache Avro, which does only support the types, not this extra additional handler Axon stuff we used. But we were at least allowed to do so, and we had a level to communicate, but they didn't write it themselves. And I think it's questionable if they should. I mean, it's the same with Gherkin files, or at least you have something that you can share, even if you are responsible for writing it. Okay, cool.
All right. With that, want to have one last round of applause for these men.